if we make the presumption that African Americans in the US on average are 80% African and 20% Caucasian, if we use these ancestry informative markers, we can a priori exclude 80% of the genome and just focus in on the 20% that is perhaps carrying the disease gene. And if we had enough markers that can hone in on the 20%, we can hone in on the signal that's emanating from that gene. And that's called admixture mapping. So that capitalizes on a phenomenon called linkage disequilibrium. I said that a marker was physically close to a disease gene. That's called linkage disequilibrium. Just physically it's close to the gene. There's nothing complex about it. Physical proximity. Well, in older populations like Africans from Africa or Norwegians from Norway, they've been around for thousands and thousands of years and been mixing. And so their DNA is all shuffled up. And because of that, the chromosomal segments are chopped up. They're small little pieces. So the physical linkage disequilibrium in those populations is very small. So these populations aren't very good for finding genes. But in populations that are like 500 years old, like Latinos, the linkage disequilibrium blocks are huge. They're big. So a marker way over here could be miles away from a diseased gene over here, and it'll still pick up the signal because of the blocks. So Latino or racially admixed populations, African Americans, which are about 300 years old, Latinos are about 500 years old, they're great for picking up the signal. And then when you got a signal, if you want it to hone in, you might want to go to a population that's been outbred, mating for thousands of years, Norwegians, Africans, Chinese, from China, to hone in on that signal. So it's kind of like having a bigger fishing net. When you get the fish you want in your net, you go in with the net that has a finer mesh to narrow down that fish. So we did that. We did that with just a small number of markers, 44 markers, these ancestry informative markers. And what Keon did, and I'm going to say it, Keon was an undergraduate in my group. We trained him. He spent 2 years in my lab. Now MSTP student at Stanford. We showed him how to do this, and we did all the testing for him, but he ran with it and was able to show that, at least in the Mexican population, the more Native American you were, the more mild your asthma was. The more European you were, the more severe your asthma was. We did the same thing for African Americans. The more African you were, the more severe you were with respect to asthma severity. The more European you were, the more mild your asthma was. This could suggest, and I will mention the caveat, it could suggest that there are African-specific alleles or Native American-specific alleles or European-specific alleles that are somehow segregating along with the European chromosomal segment or African chromosomal segment. So what we're going to do, and want Kenny to get involved, because Kenny is the expert at high throughput genotyping, is to do the same analysis but with thousands of markers. We did it with 44, with thousands of markers. And now, in the last year, we have the technology to do it. In fact, in my own lab, we're doing it with 100,000 markers. We're repeating this analysis with 100,000 markers. So the caveat is that I said that the more African you were, the more severe your disease was. What if African ancestry is a surrogate for socioeconomic status, which we know it is? What if it's a surrogate for access to care? And what if the darker you appear, or the more African you appear in the United States, the more likely it is that you get poor access to care? And so therefore your asthma is more severe, not because of something biologic, but because of something socioeconomic or access to care related. So that's the caveat. Regardless of how we pitch it, it presents a challenge, but it also presents an opportunity for us to try to untangle biologic basis versus social epidemiologic basis of disease. And that's what's important about this slide. So should I stop? It's 45. I can keep going. I got 10 more minutes. 5 minutes? All right. So despite all this stuff that I showed you, and I think I've showed you some pretty convincing evidence that there's racial differences between groups. racial differences in human performance. This topic has been quite controversial. And these are headlines of some major articles that just appeared. The problem is these aren't the Inquirer. This is not the Star. These are bellwether journals. And if you're a politician and you have the misfortune of being so naive and dumb, you get to read these headlines and run away with sound bites. Oh, there's no racial differences, therefore we should legislate, like Ward Connerly tried to do, saying you cannot collect different information on race, gender in biomedical research. Try to do that. So, in fact, one of these editors of the New England Journal even said, tax-supported trolling of databases to find racial distinctions in human biology must end. And this is a problem because we look to these guys to set the pace for the scientific community, not only in the US, but in the international community, and politicians look to these guys for the same thing. What's funny, too, is we have major scientists saying very conflicting things. And oftentimes, the folks that are saying one thing are doing another thing. So the question is this the politicization of science, or are they trying to throw off the pack? So I was at Harvard last week, and I used this slide because the guy that was at Harvard came up with this. So I won't ask if you know who it is, but basically this guy said there's no biologic basis to race. And this is Eric Lander. And for those of you who don't know Eric Lander, he is one of the modern-day pioneers of genetic research. He's the director of the Whitehead Genome Center, the Broad Institute. And this is on Nova. This is like to the general American public. And President Clinton quoted him, George Bush quoted him, all these politicians quoted him. But what they didn't hear is he also said this. But then to define variation, we sequence millions of segments from a worldwide sample of 24 people. So if there's no difference, why do that? So I think he's trying to throw off the pack. So this has been a quite controversial topic, and I've been invited now to lots of different debates on this. And like I said, I was at Harvard last week, and funny, you go there and who's leading these discussions, and you ask yourself, I ask myself, who's missing from these discussions? And really it's minority investigators, it's minority populations. And this is important. It's not because, and I think it's important, but it's important for a lot of reasons. It's important because diversity, whether it's gender diversity or racial diversity or just different experiences, provides a lot to the puzzle. It provides solutions. It provides a different way to look at problems. When you have diverse ideas going into a problem, you can have diverse answers. And in fact, this diversity is so important that, at least in America, some of the top corporations all weighed in on a U.S. Supreme Court decision in the affirmative action case in Michigan. They said that their competitiveness rested on a diverse population, emerging from a diverse educational environment. And I'll say that it's not because they were interested in minority populations. It's enlightened self-interest. The point is, diversity makes sense. It sells better. You get a better product when you have diverse folks provided. In fact, this is a study, and I know this is a little beyond this, but one of the most recent studies that came out was a heart failure pill for African Americans. Prior to it coming out, everyone cried foul. Racism, it's bigotry. Shouldn't the pill be colorblind? That was the headline in the New York Times. But what people don't realize is that the folks that wanted this study done were the black cardiologists, the National Medical Association, which is the largest and oldest black physicians group in the United States, and the Black Congressional Caucus. And then, when it did come out, the American Heart Association, which is our leading cardiology body, said this is one of the top 10 advancements in the last year. So the point is that there's clinicians, there's scientists that are seeing a problem, and they're asking for solutions. And they're asking to be part of this revolution, the scientific revolution that's going on. So Dr. Jackson, who is the head of the AAAS, which is the group that runs the journal Science, which everybody would love to have a science paper, she called this thing the perfect storm. unlike